Okay, gang, I'm on to the next question, 4.6, number 35. Now, I know when you first learn something, it needs to be repeated a few times, so you're going to have to catch this sentence and register it. If you have the secant, you replace it with the cosine and first graph that. If you have the cosecant, you first replace it with the sine and you graph that. Because then you're going to turn around and graph the inverse of that, okay, or the opposite of that. So since I have a secant here, I need to first graph the cosine. So I'm actually replacing it with the cosine, and once I draw this function, I can go back and draw this. So for the secant or the cosecant, you actually have to first graph its reciprocal. Okay, so you have to be able to read this. I'm just going to rewrite it a different way because some people don't read this correctly. I'm just going to put the 1 in front so people read it better that way. Okay, so this graph is stretched horizontally. That pi means it's stretched horizontally. This negative means it's reflected over the x-axis. This one means that it's pushed up one vertically. So I'll draw the standard table for the cosine. And then I'm going to do the calculation so that I can convert the points for this table here. So if it's inside the trig, it affects the domain. If it's outside the trig, it affects the range. So I'm going to start with the range. So what comes out of the cosine has to be multiplied by a negative and have 1 multiplied to it. So really, like this whole thing, the output of this is going to be these numbers. So I'm going to start with 1 minus, so the first output is 1, so convert to 0. Then it's 1 minus, the next output is 0. It's going to be a 1. So 1 minus the next output, which is a negative 1, be a 2. 1 minus the next output, which is a 0. And 1 minus the last output. The last output's a 1, which converts it. So I converted all of the outputs because what comes out of the cosine has to be multiplied by negative and 1 added to it. Now the input change of the inputs is a little bit more formula oriented. So the b value here is a pi, and as I said, that's going to be a horizontal stretch. All right, so let's do those calculations. So cosine, the period of cosine is 2 pi over b. We just said that the b was pi, so it's 2 pi over pi, which is 2. So the width of the function is 2 units. It's okay if it loses the pi, okay? That's not a problem. That's not a problem. You don't have to have a pi in the domain. All right, so now let's calculate the increment. Increment, that's always the period over 4. So it's 2 over 4, which reduces to a half. Okay, so that's the jump. That's the distance between the points. So it's a half, you jump a half, you jump a half, you jump a half. All right, now this is not pushed left or right. It still starts at 0, so I don't need to do the interval. Some people just do the interval because they like it, but I don't like to do it if I don't need to. So the only one you always have to do it is the tangent. And if it's not the tangent function, then unless there's a c value, like plus or minus something, you don't need to do it. Okay. So I'm going to add the increment to find the next point. So if I start at 0, I add the increment to find the next value. Then I add the increment to find the next value. Add the increment and add the increment for 2. In my head, I just like to check that it makes sense. So if my x value starts at a 0, if my x value starts at a 0 and it ends at a 2, that has a width of 2 units, which is what the period is. I just like to make sure that these values like make sense. Like from 0 to 2, that is the length of, that is the width. It's 2 units, so that lines up. Okay, so we're going to draw the new cosine function. That's what these points are for. see here if I can organize myself. Okay, let me see if I can organize myself here. I know it's a little blurry, I can see that. I'll fix it in 1 second. Okay. I'm just looking at the values because you should always pause a minute to sort of see what you're looking at. So these increments are really tiny. These are larger. The X values are jumping by 1/2, but the Y values are jumping by 1s. So I'm going to do these by 1/2. And these are jumping by 1, so these are bigger. All right, let me see if I got enough here. I think I do. Okay, oh, I got to stay in this color. Okay, so 0 is 0, 1/2 is 1, 1 is 2, 3/2 is 1, and then I go back to 0. Okay, concave down here, concave up here, concave up here. So I just want you to take a minute to put it together in your brain. Okay, so this is a cosine function that is turned upside down, horizontally. Right, this is a 3, so it's this guy is this guy's squeezed. I don't know what I said before. This guy's actually squeezed. I'm sorry. I think I said it was stretched. This guy's actually squeezed. This is a 3x. This is 3x. This is a squeeze. There's a squeeze, and then it's up 1. Okay. So in case I confuse you, reflection, squeeze, up 1. Horizontal squeeze. Okay. Let me just repeat this guy. Okay, now the thing when you draw the reciprocal graph, right, because right now this is a cosine and we actually want to draw the secant. The asymptotes are going to go through the center guy. So they're actually going to go through here. They always go through the center guy. Some people get stuck. They always think it goes through the x-axis, which is wrong. It always goes through the center point. I didn't miss a guy, did I? No, he's right there. Okay. All right, maybe one more. All right, so they're reciprocals. So as one gets smaller, the other one gets larger. So they're going to touch at each hill or valley. They're going to touch at each hill or valley, and then they go opposite. So this guy goes in the opposite direction. Opposite. Now you really only need to draw 2 parabolas up, 2 parabolas down. That's 2 cycles, but I kept going. Technically, if this was pencil, I would erase the black part because they're just floating parabolas. And you're just using the cosine to get the floating parabolas. Okay? So this is the answer to what you're looking for. The red is the y equals to negative secant pi x plus 1. That's the graph of that guy. Okay, gang, I hope that helped. I'll catch you again in another video. Bye-bye.